This video is for Math 63, and this is for the Week 6 material on units of measurement, or measurement conversion is really a lot of what we're going to be doing. I'm asking you, well, first off, in the textbook they say to memorize these conversions. You know, some of them like 12 inches in a foot. I hope that people have that memorized. If you don't, that's okay too. But those types of really common conversions, I think, are very helpful for you to know off the top of your head. Things that I know because I teach math, like 5,280 feet in a mile. If you know that, great. If you don't, it's not going to be a big deal. I'm going to base all of this on, at the end of the handout, you have a conversion, a list of conversions, okay? And you'll have these when it comes to the final exam as well. So I encourage you to work off of this. If you run into problems that you can't solve based on these conversions, let me know, and I can try to add some to it or correct it in some way. But in any event, what I'm saying is, you know, I was looking through the textbook and they say, you know, memorize these and then do the problems. We're going to be doing all of our work with a formula sheet, with a conversion sheet. Okay. The other thing about the problems in the book is that I've asked you to mostly to go through and do all of them on those pages, and so I'm not going to do the even problems there. I'm going to focus on the handout. Okay. We have about 70 or 80, about 80 problems on the handout. So I'm going to go through, I'm going to do a bunch of even numbered problems from here, and I'm going to use that conversion sheet to do it. So let's go ahead and take a look at these. And this is I think this is a really useful topic. You know, it comes in handy in the sciences, in the healthcare field. We'll kind of revisit this during the last week of the term with problems that are more specifically directed to the healthcare industry, basically. And these kinds of conversions come about, you know, all the time. People use different units of measure. The example that I always remember, when I was in college, a friend of mine was taking a course on the history of the Vietnam War. And at that time, let's see, I think that was about 1986, somewhere around there. So the war had really only been over for about 10 years. So anyway, the content for the course, rather than using a textbook, they were watching a documentary called Vietnam, the 10,000 Day War. So let's just talk about that for a minute as an example. Okay? And I think that the makers of that series, I think it's a TV series from Canadian television, I think they did this on purpose to get across one of their main ideas about the Vietnam War, is that it was not just what happened in the 60s and early 70s. There was a lot more to it. I'll come back to that in a second. First off, 10,000 days. Well, just how long is that, you know? Well, if we can make a conversion, so 365 days in 1 year, okay, well then we have to find out how many years are in these 10,000 days. And we could use 365.25 if we wanted to. It's not a nice even number for how long it takes the Earth to go around the Sun. And also how long it takes the Earth to go around itself. These things are not nice round numbers, and that creates some difficulty in making calendars, which is another subject that I'm pretty interested in. But in any event, let's go ahead and solve this problem. In doing these problems, the question is often going to be, do we multiply or do we divide? Okay? And so, you know, one thing that you can look at is that if you've got a smaller unit, right, you will have more of them. If you have a bigger unit, you will have fewer of them. And that relationship should always stay the same. You're going to have more days than you do years. So we don't want to multiply these two together, right? We're going to divide them. 10,000 divided by 365. Let's see here. Okay, 10,000 divided by 365, so is about 27 years or so, somewhere around there. And so the point that I think this documentary was making, like I said, was that this had been going on since the end of World War II. Okay, the unrest and political difficulties in Vietnam came out of World War II and really were a product of colonialism, in my opinion, and I don't think that there's a lot of debate about that. The war itself and the American participation in it was the subject of quite a lot of debate. But in any event, I've always liked that idea, the fact that there was a lot more going on in Vietnam than just what was going on in the 60s. Okay, so let's look at some more problems here. So on the first page of the handout, we're talking about length. And problem 2, nurse measures the height of a patient as 71 inches. Convert this to feet and inches. Okay. Well, again, you've got this on your conversion sheet, but like I said, this is the one that I think most people do know. 12 inches make 1 foot. Again, do we want to multiply or do we want to divide? In this scenario, we're going to be dividing 71 divided by 12. Now, this has its difficulties. Okay, so let's see. What happens if we do 71 divided by 12? We get, let's see, 5.916 repeating. Now, the problem doesn't ask, for this answer right here. It asks for the answer as feet and inches, okay? So we know that there's going to be 5 feet in there. So if we do 5 times 12, that means we've got 60 inches for that 5 feet. And then what's going to be left over is going to be 11 inches. So the answer to this question is 5 feet, 11 inches. Okay? And, if you do these calculations, in your head or something, this one in particular, that's fine. You don't have to actually go ahead and do that subtraction. You can look at the 60 and the 71 and know that there's going to be a difference of 11 inches. But that's the process here sometimes. I think pounds and ounces frequently works like that as well. And a lot of that is because our number system is in base 10, but feet and inches is not. Okay? Because there are 12 inches in a foot, and the same thing with pounds and ounces, because there's 16 ounces in a pound. When you go ahead and divide those, your decimal is not going to be representative of how many ounces are left over. Okay. Problem number 6. So again, this is a feet and inches problem. So Evan is 4'3". Mary is 3 feet 8. How much taller is Evan than Mary? Okay, well, we want to find the difference in their heights. So that means we want to subtract. Now, we can go about doing this as a subtraction problem, but we're going to run into some issues here again because this is not, feet and inches are not a base 10 scenario. So another way to go about doing this is to think about, if you've got 3 feet, right? And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 4 feet at 12 inches. And then 1, 2, 3 inches. Okay, so there's 4'3". 3'8" is 1, 2, 3, 4, 5, 6, 7, 8. There's our 3'8". What's the difference? 1, 2, 3, 4, 5, 6, 7 inches. Okay, there's our answer. That's one way to do this. You can do it without the diagram, right, you can take 3 feet 8 and just go 1, 2, 3, 4, 5, 6, 7 inches. Okay, same thing. Okay, so those two, these are basically the same approach. Okay, one of them has a nice little diagram, and the other one doesn't. If you want to do this by subtraction, then this is, not something I'm suggesting that you're going to have to do. I just happen to find it interesting. Which is that you can borrow here in the same way that you borrow in a regular subtraction problem. But if you borrow from the 4 to make it a 3, this foot that you're borrowing over is 12 inches that you have to add on to that 3 inches. Normally when we do some subtraction, if we were doing, let's say 93 minus 47, you borrow from the 9, make it 8, you just put that 10 right there as a 1, right? That's not the way it works here, because the 10, you can do that. Here, you're adding a 12, so that's going to be 15 inches, that's going to be 8 inches. Our difference is 7. We already talked about that. Okay, so again, there's a couple different ways to go about doing that, but it's important to remember that things like feet and inches and pounds and ounces, those are not base 10 units, and so that they work a little bit differently. All right, problem 8. Pediatrician has a standard growth chart, 3 feet 1 inches. The minimum height shown on the growth chart is 3 feet 1 inch. Okay, 3 feet 1 inch. If a 4-year-old girl is 3 inches below the minimum height, what is her height? Okay, well, we don't have to count too far down, so it's easy just to count. Like, we only have to count 3 inches, so 1, 2, 3 inches would make the person, this 4-year-old girl who's 3 inches below the minimum height, that would make her 2 feet 10 inches. And again, you can do the subtraction if you'd like. 3 feet 1 inch minus 3 inches, borrow here, add 12 inches there, 13 minus 3, 10 inches, 2 feet. There we go. Okay. So, that's it for the height problems, or the length problems. And these, you notice that these are all about English units, to English units. We haven't talked about the metric system yet, so we will get into some metric system problems, and also metric English conversions. All right, so now we're into pounds and ounces, and let's see, let me double check here. Yeah, on our conversion sheet, we've got 16 ounces equals 1 pound. All right, problem 12. The average weight for a newborn baby is 7 pounds, 8 ounces. In September of 2009, baby Akbar was born in Indonesia, weighing 19 pounds and 3 ounces. Goodness. Okay. How much more did baby Akbar weigh than the average newborn? So again, and this one, it's kind of hard to count up. I mean, I suppose you can do this. So I'll do that first, and then we'll do the subtraction. Okay, so if you've got 7 pounds, 8 ounces, it would take 8 more ounces to bring you up to 8 pounds. Okay, and then if we added another 10 pounds, that would put us at 18 pounds. Add another one, and that would be 19 pounds. And then add 3 more ounces, and we're at 19 pounds, 3 ounces. So this is what we've had to add to get from 7 pounds, 8 ounces up to 19 pounds, 3 ounces. And you can do this in any way that you want, so long as you're doing it correctly. But let's see. So we had to add 11 pounds and then 11 ounces. Okay? Well, let's do the subtraction and see what happens. 7 pounds, 8 ounces. All right, so again, we're going to have to borrow here. Borrow 1 from the 19, make it 18. But when we bring it over here, it's 16 ounces. Okay, so now we're doing 19 minus 8. That's 11 ounces. 18 minus 7, 11 pounds. And there we are, 11 pounds, 11 ounces. And either one of these is fine. The difficulty with this one can get, the more challenging the problems get, the more convoluted this process becomes. The only trick here is that you have to remember, if you're going to borrow, you're going to be borrowing 16 ounces. Okay. Let's look at some more of these. Problem 14. Hospital kitchen has a 50-pound bag of flour. Okay. At the end of the week, 3/4 of the bag was used. How many ounces of flour remained in the bag? So again, notice the question is in different units than what we were given. We want to know how many ounces remain rather than how many pounds. Okay. So let's see. So first off, we have to figure out how many pounds were there at the end of the week. Okay. So if 3/4 was used, that means there's 1/4 left. Now you can multiply 3/4 times 50 and subtract, or you can just multiply 50 times 1/4, and that should give us 12.5. Double check that. 50 times 1/4, 12.5. So there's 1/4 left. That means there's 12.5 pounds. And we know that there's 16 ounces in 1 pound. Okay? So again, here's the decision. Do we multiply or do we divide? Okay? Well, again, this conversion will hold true. Now, you can set up a proportion. Okay? So let's say you say 16 ounces is the same as 1 pound. Then 12.5 pounds will equal X ounces. And there it is right there. You're going to multiply these two and divide by that one. Okay, so 16 times 12.5, 200 ounces. And there we go. Okay, so again, those ideas about proportion and percent that we were talking about before the midterm really don't go away. I mean, frequently they're in the background as people are solving these problems. But like I said, if you ever have difficulty, well, what I was saying is that the choice here is, do we multiply or do we divide? If you set up a proportion and do it correctly, that will always answer that question for you. So if you're ever not sure, you can try setting up a proportion. Okay? All right, let's see here. So that was problem 14. Now we go on to the next page. Now we've got some conversions for time. So that's like that 10,000 day problem that I was talking about a few minutes ago. Let's see here. In problem 32, we're converting 555 minutes into hours. 555 minutes equals how many hours? Now in some problems, like I'm going to do problem 36 in a minute, some problems there's an intermediate step that you might have to do. Here, we can just convert directly from minutes to hours. Okay? We know that 60 minutes is 1 hour. Okay? And so we can just go ahead and we can make this calculation, 555 divided by 60, and see how many hours that's going to be. 9.25 hours. Now, like I just said, if you're not sure about that, you can set up a proportion, right? We know 60 minutes is 1 hour. So if we've got 555 minutes, how many hours will that be? Multiply here, divide by that one, and that answers the question. Do I multiply or do I divide? Okay, here we would divide those two numbers. Okay, so problem 36. Now what I said a few minutes ago is that there's an intermediate conversion that you have to do here. So problem 36 we've got, and this is very common as well, 12,600 seconds. And we want to convert that into hours. Okay. So if you look at your conversion sheet, what we've got is, 60 seconds is 1 minute. And 60 minutes is 1 hour. And this is pretty common when it comes to converting units, is that sometimes you don't have a direct conversion from seconds to hours. Now you can create one for yourself if you want to, but that's also an intermediate step. Okay? Or we can do two conversions. We can first change the seconds into minutes, and then we can take those minutes and change them into hours. And both of those are going to be dividing by 60. Okay? So, let's see here. If we take 12,600, divide it by 60, then that'll be 210 minutes. 210 minutes, and then we'll take those 210 minutes, divide that by 60, and that'll be 3.5 hours. Okay? And again, if you wanted to set this up as proportions, 12,600 seconds, how many hours? Well, actually, we can do it directly if we want to, but really, I think the safe one, it's slightly safer to go first into minutes, knowing that 60 seconds is 1 minute. And again, notice I'm putting the seconds on top, the minutes on the bottom. Doesn't matter where I put them, what's important is that they match up. Okay? You can't put seconds here and minutes here. Alright? So here it is. We're going to multiply these, divide by this one. And so there's that answer. And then we could take those 210 minutes and then convert them into hours, knowing that 60 minutes is 1 hour. Multiply these, divide by that one. Okay. All right. Well, that's problem 36. Let's see what else we've got here. Oh, now problem 40, we want to go into days. All right. So 5,040 minutes. How many days would that be? Well, let's see. So the conversions we need are 60 minutes is 1 hour, and 24 hours is 1 day. Okay. So again, we can go ahead and divide 5,040 divided by 60. Says that this is going to be 84 hours. And that was by dividing. And then we'll take the 84 and divide that by 24. And that comes out to 3.5 days. Okay? All right, now we get into these, let's see here. Oh, actually, so let me pause here for a second. I missed a page here on the weight and liquid capacity. So I'm going to go back and do. There's 3 of these problems that I didn't talk about. So let me back up for a minute and talk about these, and then we'll go on and finish up with the metric and English conversions. So let's go back and do problem 16. Baby weighs 7 pounds, 8 ounces at birth. 6 months later, the baby weighs 15 pounds, 13 ounces. Find the baby's increase in weight. Now this one really lends itself to subtraction because you don't have to borrow. 15 pounds, 13 ounces, minus 7 pounds, 8 ounces. And you've just got a straight subtraction here. 8 pounds, 5 ounces. Pretty straightforward. Okay. Let's see here. Problem 18. Massage oil weighing 5 pounds, 4 ounces is divided equally and poured into 4 containers. How much massage oil is in each container? Well, you know, theoretically you could divide this by 4, but I think really the best way to go is to change this all into ounces. Okay? And we know that 16 ounces is 1 pound. So if we do 5 times 16, that's going to be 80 ounces, plus the other 4 is 84 ounces. We want to divide that evenly into 4 containers, and so each container is going to have a weight of 21 ounces. Okay. And then one more here, and this is on the section for liquid capacity. The staff, problem 20, the staff at a healthcare facility planning a July 4th party. 200 residents will drink 1 cup of punch each. 200 residents, each will drink 1 cup. And how many gallons do we need? So this is essentially saying 200 cups equals how many gallons? Now you could take this whole thing and convert it all into ounces, you know, and that's one way to go about doing this. I'm going to kind of build this up. Let's see, 200 cups, let's take our conversion sheet. So there's 8 fluid ounces in 1 cup. 2 cups in a pint, and 2 pints in a quart, and 4 quarts in a gallon. Okay, so we've got a choice here. We can build a conversion factor to go straight from cups to gallons. That's one way to go about doing it. Or we can do successive conversions, where we go from cups to pints, pints to quarts, quarts to gallons. Okay? However we go about doing it, we're going to be essentially doing the same thing. So let's go ahead, let's change our cups into pints. Alright? We know that there's 2 cups in every pint. It takes 2 cups to make a pint, so that means 200 cups is going to be 100 pints. Right? And then 2 pints in a quart. So those 100 pints are going to be 50 quarts. And then again, 4 quarts to make a gallon. So 50 divided by 4, 12.5 gallons is what we'll need. Okay? The other thing I was talking about is you could change this all into fluid ounces. Let's see here. There's 2 cups in a pint and 2 pints in a quart. So that means there's 4 cups in 1 quart. 4 quarts in 1 gallon means that there's 16 cups in 1 gallon. So we could just take that 200 and divide it by 16, and that should give us the same answer. 12.5, exactly. Okay? You can do the same thing with fluid ounces. You can make everything in terms of fluid ounces and then compare them that way. But however we go about doing it, we should always come out with a 12.5. All right, now let's go back, start in on these English to metric conversions. All right, problem 52. We want to convert 100 yards into meters. Okay, so the single m represents meters, right? If you see this, that typically means miles, okay? So don't get confused by that. If you see just the single m, that usually represents meters. All right, so let's look at our conversion sheet. So that middle section is all just metric to metric, how to convert from metric to metric, and there are those problems in the textbook to help you practice that. We're going to be looking at these bottom questions. Let's see here. Inches to centimeters is not really going to be that helpful here. 1 meter equals 3.28 feet. Okay, that might be helpful. And then the other one, 1 mile to 1.61 kilometers, that's not that helpful. I'm going to use this conversion right here. We know, let's see, so the 100 yards is 300 feet, right? Because there's 3 feet in a yard. Okay, so now we know we're working with 300 feet and we want to know how many meters that is. So again, if you're not sure, we can set up a little proportion here. Multiply here, divide by this one. So we're going to be doing 300 divided by 3.28. And so it's going to be about, I'll call it 91.46. Okay, there we go. Let's see here. Problem 54. This one's about height. Person is 5 feet, 8 inches tall, and we want to know how many meters is that. Okay. Well, again, our conversion here, we know that 1 inch equals 2.54 centimeters. So I think that'll be helpful for us. Let's see. So what I'm going to do is I'm going to convert this all into inches. The 5 feet times 12 is going to give us 60 inches plus the 8. So this is 68 inches total. Okay. Now the question is, how many centimeters is that going to be? Again, the question is, do we multiply or do we divide? In this problem, we should be multiplying, okay? 1 inch is 2.54 centimeters. We've got 68 inches, and we're going to convert that into centimeters. Multiply here, divide by 1. So yeah, 68 times 2.54, 172.72 centimeters. And so, remember the problem was asking, where are we? Problem 54, the height in meters. So most heights, when people are talking about the metric system, are given in meters, okay? And so we know that 100 centimeters equals 1 meter, because that's in that middle section on our conversion sheet, right? And that's what the prefix centi means, right? It's the same prefix as cents, because there's 100 of them in a meter. All right? So if we divide this by 100, then that tells us this will be about 1.73 meters tall. And that's, like I said, this is a standard way that Europeans express heights, is in terms of meters, 1 point something meters. If someone's really tall, they'll be 2 point something meters. All right, let's see here. Problem 56. We've got a weight question. Let's see, what is this one? A 15-pound baby, how many kilograms is that? So, 15 pounds equals how many kilograms? Let's look at our conversion page here. And again, we've got 1 pound is equal to 453.6 grams. And so if we change this into grams, then we can change it into kilograms. Very similar to what we did here. We changed this into centimeters, where is it? Right here. And then we turn the centimeters into meters. Okay, so every pound is 450 some grams, and we've got 15 pounds. That means we're going to multiply 15 times that conversion factor, 453.6 times 15, 6,804 grams. Now, we know that there's 1,000 grams in 1 kilogram, and again, that's on the conversion sheet, and also this prefix kilo means 1,000. Okay? All right, so we need to take this, divide it by 1,000, and that'll give us about, we'll use about 6.8 kilograms. Okay? If you want to put the 804 on there, that's fine. Okay, well, let's look at a few more of these problems here. All right. Problem 60. Got 65 miles per hour. And I'm going to write that out. And we want to change this into kilometers per hour. Although actually, if that's all we're going to do, I don't necessarily need to write this out. Miles per hour to kilometers per hour. All we really have to do is change the miles into kilometers because the hours are the same. What's really tricky is if you go from miles per hour to like meters per second, that's a tricky conversion. Okay, so this one's not so bad. We just need to go from miles to kilometers. We know 1 mile is 1.61 kilometers. So again, there's always going to be more kilometers than miles. Okay? So our answer should reflect that. So if we've got 65 miles per hour, the question of do we multiply or do we divide, we're going to multiply by that 1.61 so that our answer gets bigger to reflect that we need more kilometers to represent that same distance. So 65 times 1.61 gives us a 104.65. So 104.65 kilometers per hour. Okay. Let's see here. Problem 62. Calcium carbonate costs $9.50 per pound. Find the cost per kilogram. Well, let's see here. Again, we need to convert from pounds to kilograms. So what are we going to do here? 1 pound equals 453.6 grams. All right. Well, let's see here. There's a variety of different ways we can go about doing this. We're interested in the price for 1 kilogram. So how many pounds are in 1 kilogram? So 1 kilogram is how many pounds? Well, see, that's the thing. I'm going to set up a proportion here, but my conversion factor is for grams. So let's turn these kilograms into grams. All right, so 1 kilogram, 1,000 grams. So then we'll come down here, we'll make this 1,000 grams. Then we can put our 453.6 up there, our 1 pound here, multiply those, divide by that one. And what do we get? 1,000 divided by 453.6 comes out to about 2.204. .204.6. Okay, so that's saying that 1 kilogram is about 2.2 pounds. Now, do we have that conversion? Yeah, see, we've got that conversion already on the conversion sheet. I just didn't see it. So this conversion is actually a lot easier than I'm making it out to be. So anyway, all we have to do is take that 2.2 pounds and multiply it by 950. So 2.2 times 950, that gives us $20.90 per kilogram. Okay, so in any event, what's the moral of the story here? Take a close look at your conversion sheet and make sure that you're working with one that is the easiest to work with. Okay, I did a lot of work here I didn't have to do. It didn't really cost me anything, but it is a lot easier if you pick the conversion that is easiest. All right, let's see, what else do we have here? Yeah, let's look at problem 64. Gasoline is $3.87 per gallon, and the question is, what is the cost per liter? All right, so gallons to liters. Yeah, we've got a nice direct conversion here. 1 gallon is 3.785 liters. Okay, so again, the question is, do we multiply or do we divide? Okay, let's see here. 1 gallon. So this cost $3.87 is for 3.785 liters. So we need to divide these two. It's going to come out to be just about $1 per liter. So 3.87 divided by 3.785 comes out to about $1.02. 1.02 per liter. Okay. All right. Let's see here. All right, let's look at the last one on here, problem 80. What do we have? 500 milliliters of acetone alcohol costs $14.10. Find the cost per fluid ounce. Cost per fluid ounce. All right, so we need to take those milliliters and convert them into fluid ounces, and we do have a nice direct conversion. 1 milliliter is 0.034 fluid ounces. So, now again, the question is, do we multiply or do we divide here? Well, we're always going to have the number of milliliters is going to be bigger than the number of fluid ounces. So, does that mean we multiply or does that mean we divide, right? Because often when we divide, that gives us a smaller number. Here, if you multiply this, you'll get a smaller number. And if you divide by this number, this will get bigger. All right, so let me set up a proportion so we can talk about this. 1 milliliter is 0.034 fluid ounces. Over here, 500 milliliters is going to give us some number of fluid ounces. But here it is. There's the multiplication, and that division by 1 won't change it. Okay? So that's why you have to be careful about making your choice about multiplying and dividing. You can always check it out by making a proportion. All right, so 500 times 0.034, 17 fluid ounces for $14.10. And so we need to divide this by 17. 14.1 divided by 17 comes out to about 83 cents. 83 cents per fluid ounce. And there we go. Okay, so like I kept saying, these problems involve a certain amount of decision making, okay? You want to look at your conversion factor, you want to look at what you're trying to convert, and then you want to make that decision, do I multiply or do I divide? If you're not sure, or if you made a calculation, you want to check it out, you can always set up one of these proportions, okay? And this will help you to make that decision, do I multiply or do I divide? Okay, so as always, if you have any questions on these problems, please let me know. And like I mentioned, we will come back and revisit these ideas in a couple of weeks when we apply this to dosage calculations for the healthcare industry. Thanks a lot. Bye.